Alright, welcome to some new slides. The topic now is loops. Let's get right on into it. So the word means exactly what you would think. Like, we have programs that we would like to do this with. We'd like to have them loop and come back around on themselves. That's very exciting and will be very fun for us. Alright, so I shouldn't need to motivate this too much. I've shown you a very good example of why we would need to loop in programs. Alright? Because we've been doing this, right? I copied and pasted way too much code before to do that guess the number game, and that's just not right, all right? What we would like is to have our programs revisit and rerun existing code so that I don't have to keep copying and pasting it, all right? That's what I would like to do now. So what our programs look like right now, what we know how to do so far is make programs that look like this, right? We got straight line stuff that happens one after another, and then we know how to branch now too, so we can go off, do some things over here or some things over here depending on like a condition check. Don't have to do as many things. We'll be doing different things, right? That's the whole point. And then maybe come back together and then do some more straight line stuff, rinse and repeat. All right, that's what we know how to do right now. What we would like to do today, what we'd like to do in addition to all that, of course, is this. All right, let's combine everything. I want to be able to branch off, do straight line things, come back, and then finally, this, all right, loop. Come back and redo all this code. Maybe like we took this path the first time, take this path the next time. That's beautiful, all right? So that's where we're going, and I will draw that in rainbow and circle it, because that is the goal, okay? That's where we're going today. That's what a loop is. We're looping back around on stuff that we've already done. So that's my motivation. Hopefully that makes sense. And so let me teach you the easiest kind of loop in C++. It's called a while loop. The syntax looks a whole lot like an if statement, doesn't it? It's very, very similar. All right, so what a while loop does is it looks like this. You say while, then you give a Boolean expression, something that can become true or false. And what it will do is it will run its body as long as this condition is true. So eventually, like, things are changing in the body that change this condition's result one day, and then it stops. But like that's pretty much it. All right, so that's how a while loop works. Like, you come into it with like dots above, and then you come into the Boolean expression, and it's just like an if statement in that regard. Like, it tries the Boolean expression as long as it's true. If it's true, it runs the body. But the difference is that as long as it's true, it keeps coming back, right? Rerunning the body. So it's always condition, body, condition, body, condition, body. It reruns it all as long as the condition remains true. But eventually, hopefully, your variables will change, and your Boolean expression will eventually become false, and that will stop your loop. Then you're done, and you go down to the rest of your code. All right. So in essence, this body, we say it's repeated while. That's why it's a while loop. It's repeated while that expression is true. Repeated while your Boolean expression in the condition evaluates to true. Okay, so let me show you the simplest example of a while loop. Let's make one that prints all the numbers from 1 to 10. All right, let me show you the secrets there. So I'll make a new file called, I guess, 1 to 10.cpp. And so no more of this, right? No more cout 1, cout 2, because that's all we can do right now. That's the only way we could make this work. There's a better way. Instead of like counting these variables, 1, 2, 3, 4, or counting these like hard-coded numbers, let's output a variable, okay? Because like here's something that we can repeat. Let's make a variable called I and like start it at 1. I can print I, and then do this, right? I++, make it 1 more than it used to be. So that prints I, right? Print I, and then increment I. Do you see how if I started I at 1, I just copied and pasted that a few times, it would print 2, 3, 4, 5. It would, right? It's 1 the first time, now it's 2. Now it's 2, prints the 2, makes it 3. Now it's 3, makes it 4. But I'm copying and pasting it. I could loop this. Here's the goal. What I want to do is repeat that code, right? While something's true, I want to repeat all that code. And essentially, the thing I want to check for true is like while I should be printed. It's one of the numbers I want to print, right? Well, I is a number I want to print. Does that make sense? So like, what does that mean? How do you check that? Well, it depends on how far you're going. If I want to print up to 10, while I want to go while I is less than or equal to 10, because it's going to start at 1, it's going to go all the way to 10, and eventually it'll print 10, make it 11. Comes back to this check. 11 is not less than or equal to 10. All right, so that's kind of the hand-wavy argument for why that's going to work. And look at it. There it goes. So hopefully that makes enough sense. I'm just repeating this code, essentially. I'm copying and pasting it 10 times, and this condition is enforcing that. So like the first time it was 0, or it was 1, print made it 2, 2 is still less than or equal to 10, then it prints the 2, makes I 3, and then it's always coming back to the condition, right? It's always coming back to this check. As long as that thing is true, we run the body. So all right, 3 is less than or equal to 10. Print 3, make I 4. 4 is still less than or equal to 10. Print 4, make I 5, all the way to this. Like 10 is less than or equal to 10. Print 10, make I 11. Hoo-hoo. Come back to the check. Is 11 less than or equal to 10? No. So it stops. Then we're done with the loop. All right, so that's how that works. And so if I were to print I right here, it is in fact 11 right now. All right, let me prove that to you. There it is. It really was 11. That's what stopped this loop. That's what made it false. All right. So I is 11 right now. That's what stopped the loop. So there's that. What else? Let's also sum up all the numbers from 1 to 10. I want to do that for you now. All right. So I guess before we get there, let me draw a picture of like why the printing code worked, just to make sure we're all on the same page. Let's put let's see. Let's get these closer together so I can take an easier screenshot. There's that. And then, yeah, let me draw before we get to more things. There's that. And so here's what happened. I made this I variable, started at 1, and then I ran this loop. All right, and what it did was it just continuously checked the condition and then ran the body as long as it was true. All right, so the very first time is 1 less or equal to 10. Yeah. So it runs the body and prints 1, and then increments 1 to 2, right? I plus plus, I is now 2. All right, then we come back to our condition. Is 2 less than or equal to 10? For sure. Print the 2, make I 3. 2, make I 3. 3 is less than or equal to 10. Print the 3, make I 4. You see what's happening? All the way, right, to it's eventually going to print 9, because I is 9, right? One day, I becomes 9. 9 is less than or equal to 10. Prints the 9. 9 plus plus, right? So there it is printed, and we made 9 10. I plus plus makes it 10. Come back to the condition. 10 is less than or equal to 10, so we run our body again. We print the 10. Make I 11. Make I 11. Bam. And then we come back to our condition. Check it one last time. Is 11 less than or equal to 10? It is not. So that stops our loop. All right, that's the secret. That's why it's going to work. That's why we get the right output. Okay, so do yell at me if you have any questions about this stuff. But I hope you can kind of see how we might change this to, instead of printing a bunch of numbers from 1 to 10, add up all the numbers from 1 to 10. Because this I variable, what it was doing is it was taking on all the values from 1 to 10. And if I just like hook into that, maybe instead of I, I'll use j this time. If I hook into that with a loop, like start it at 1, and have some other intermediate variable, like sum, I can keep adding into, like I'll do the same thing with the j variable and just keep on shoving it into the sum variable. Like, all right, add 1 into it, make it 2, add the 2 into it. Now it's 3, right? Make j 3, add the 3 in. I'll just have j range over all the values from 1 to 10, right? And then add the 10, right? All the way there. And eventually it will hold the right sum from all the numbers from 1 to 10. And I think the right answer is 55. And then we'll stop the loop because we'll do j++, make it 11. But we won't add in the 11. Yeah, that's the secret. So I hope that makes sense. And let me show you that code now. So similar idea. Let me actually copy and paste all this all over again. So you can see I'm just going to change I to j. Oops. There we go. Boop. And so I guess let's get rid of that. And it's not I++ anymore, it's j++. So again, this is just going to print from 1 to 10 again. Let me do a new line so we can see. So this is all just going to print from 1 to 10 right now. Instead of the printing, what I'd like to do instead is keep on adding into some other variable called sum, all right? Sum equals sum plus j. So let me try to explain that. So I want to repeatedly, instead of printing, I want to repeatedly add this value of j into sum exactly 10 times, right? And increment j each time. Because that'll make it 1, then 2, then 3, right? And so this will let it go up to 10. And then, yeah, so this line, hopefully you can see that, like, j is 1. It'll add 1 into sum the first time. And then j++ adds 2 into sum the next time, right? 3 the third time for the same reason, because j++, we get back here, now j is 3 the third time, all the way to 10, right? I'll add the 10 in, make it 11, and then we're done, we stop, okay? So by the time this is finished, we can output sum. Sum holds the correct sum of all the numbers from 1 to 10. And it is 55. Isn't that cool? So instead of printing, again, just like adding in each value of j, each valid value of j into the sum variable. That's pretty cool, all right? That's useful knowledge, useful information. So now I want you to try. Change this code. This is our print from 1 to 10 code, just with different colors. Change it so that instead of printing from 1 to 10 in that order, I'd like you to have it print from 10 to 0 in decreasing order. All right? Give that a try. Oh, and by the way, if you run into issues, if you ever run into a runaway loop to get back to the terminal, you do Control, even on a Mac, you do Control-C, all right? That's what you do. That's how you stop a runaway program. But do you see how you would change things? Instead of printing from, this code is printing from 1 to 10 ascending, we want to print from 10 to 0 descending by 2s, all right? So what needs to change? Do you see it all? Well, this thing right here, the first value that we start at, shouldn't be 1, right? Because like that's what's going to get printed the very first time. It shouldn't be 1. It should definitely be 10, right? If we fix that, make that 10. And then, all right, it's 10. We print our 10. We want to like print 8 next, right? We want to get to 8 next. So we can't be doing I++ because that would make 10 11, wouldn't it? So this needs to become something different, right? I minus equals 2, like somehow make it smaller, right? Plus is the wrong direction, yeah? And then finally, this condition is a problem, right? Because if we go in this direction from 10 all the way to 0, it's always right? It's always less than or equal to 10, our I variable. Starts at 10, 8's still less than or equal to 10, so is 6, 0 is less than or equal to 10, -2 is less than or equal to 10. Like, it'll never stop if we do it that way. So we have to go in the other direction. It's got to be like a greater than or equal to. So let me show that to you. All right. So I hope you got that. You noticed it. If you ran into like a program that never ended, Control-C is the answer, okay? So because I already have I can't say int anymore. I just have to reassign it. But I think we see what needs to happen, right? I starts at 10. We would like to like print the 10, then make it 8, right? Make it 8 next. So it's I equals I minus 2. That's how you can do it. A shorthand for that is I minus equals 2, okay? And then this condition is the last thing that needs to change. Instead of, it's usually, the hint is, the condition should be something involving the last number. So it has to be something involving 0. And this won't work. It's the wrong direction because 10, right? We want it to be true at the start too, right? 10 is not less than or equal to 0. So that's a hint to change the direction. Like we're going until we hit like -2, then we stop. That'll fix it. Boop. So that should do it. And here, let's have a new line in between there. But you can see what's happening, right? There it really is. All the way to 0, and then it stops, right? Because we print the 0, make it -2, and then -2 is definitely not greater than or equal to 0. So yeah, that's loops in a nutshell. That's a while loop. That's pretty nice. We can repeat code that way. And I just want to stop and like so we can all be in awe of this moment together, because this is huge. With this knowledge of while loops, that plus like if statements plus strings, like plus the other stuff we already know, we can do something really, really cool with our current knowledge. All right, so Alan Turing, very famous man, very sad life, unfortunately. He invented the Turing machine. We made a Turing Award after him, which is like what's it called? The Nobel Prize of Computer Science. So like he invented a mathematical thing called a Turing machine, which models how computation gets done. It models how every computer that has ever been made or ever will be made, except for quantum ones, I guess, will ever work. All right, so every program under the sun can be modeled by a Turing machine, even the ones that still have not been invented. And it just so happens that the addition of loops into our arsenal of knowledge in C++ right now lets us simulate any Turing machine that anybody could ever think of. So that means that technically you, at this point, can create any program that has ever existed or ever will exist. Technically. Because you can always model it as a Turing machine. Isn't that cool? So yeah, pat yourself on the back for getting this far. You can essentially write anything at this point with enough time. You might be asking, like, why in the world don't we stop the class now then? Let's all be free and get A's, and then we never have to like come back here and do more assignments. Well, hopefully you can see like there are ways to make your life a lot easier. Like I haven't taught you how to make your own functions yet. Like that would change the game, wouldn't it? Technically it's unnecessary, but I think you would like to be able to do that, right? So there's plenty of things that would like improve your quality of life as a programmer that I have not yet got to. But technically it's all not necessary, all unnecessary. So yeah, you can simulate any Turing machine now, which is fun. So yeah, enjoy. And then now let's talk about issues, right? Because with great power comes great responsibility. Now you have the potential to mess up in new ways with loops, right? You can make a new kind of bug, a program that could possibly run forever. All right, so here's the simplest program that runs forever. You just say while, and then in your condition, give a condition that could never possibly become false, right? The easiest one is one where you just say while true, right? That condition, true is always true. So that will be an always true condition that will run its body until the end of time, all right? And again, like I said, Control-C, even on a Mac, Control-C is what you type to stop a runaway program and get back to the terminal. So let me show that to you. And then also, there's a fun pun. The original Apple headquarters in Cupertino, their address, because like they were so big, they made their own street. So their street name was Infinite Loop, and they were one Infinite Loop. So that was their address, or it still is. They just use a different headquarters these days. So you get the joke now. So yeah, let's do an example of an infinite loop that is, I guess, somehow not, like this is too easy, right? Let's do one that's like more subtle here. Let me take this code and like mess it up somehow. What could I do? Yeah, so let me mess with this code. It's gonna work right now. Let's make that not true. So let's say that like we accidentally did a condition involving the first number instead of the last number. So like 1 is greater than or equal to 1, so is 2 and 3, all the way to 11 and 12, all the way to infinity, right? So this is a more subtle bug. Infinite loop, it will never stop. It's just going to start counting up and never get to the end. So I'm going to press Control-C to get back to the terminal and stop this runaway program right now. All right, it's counting pretty fast. Technically, this will end if you think about it. If you learn, well, you'll have to wait until CSCI 45 to fully understand it. But eventually, the numbers will wrap back around to become negative. But morally, this is an infinite loop. All right, so I want you to think of it as one, at least in CSCI 40. But technically, that would eventually stop if you waited long enough. But yeah, while true, simple infinite loop. Okay, so yeah, with that, let's talk about some cool algorithms that involve loops. So I'd like to teach you the first algorithm that was ever invented, actually. It was invented back in the BC era. It's the first one that anybody ever wrote down. We didn't have computers back then, but like it was still useful, just on pen and paper. So it was invented by the mathematician Euclid back in 300 BC. It's the world's first algorithm. I get to teach it to you now. All right, so here it is. What it does is it computes the greatest common divisor between two numbers, And hopefully you remember what that means from math class, right? The greatest common divisor is the biggest number that goes into two different numbers. So you can ask for like, what's the greatest common divisor of two numbers, like 12 and 18? And what you do is you find the biggest number that goes into both. One way to do it is to write out their prime factorizations and circle the ones they have in common. And then you multiply them together. And so that's 6 for 12 and 18. 6 is the biggest number that goes in cleanly to both of those numbers, both 12 and 18, all right? But this is hard, especially for bigger numbers, to like break it down into these prime factors. And so there's a quicker way. Here's the algorithm. All right, so let's call the two numbers that we want to take the greatest common divisor, or GCD of. Let's call them A and B. And then here's the algorithm. We need a while loop. While B is not equal to 0, then I will replace B with this computation. I'll take the remainder after dividing A by B. So that's like a percent sign modulus operation there. So I'm going to replace B with that. And then I'm going to replace A, the value of A, with the previous value of B before I changed it on this line. Okay? And then eventually, like the loop will stop when B becomes 0. And when that happens, apparently, A holds the greatest common divisor. So it has nothing to do with prime factorizations or anything. It's going to converge a whole lot faster. It's really, really nice. All right? So let's kind of translate this to code now. Let me show you how. So while B is not 0, so your condition would be something like this. While B is not equal to 0, what do we do with this? Replace B with the remainder from dividing A by B. What is that? That's something like this, right? B equals A mod B. That's exactly that. And then replace A with the previous value of B before we ran this. So we kind of have to save the old value of B up above in between so that we can do this. A equals like old B. Name it that. So we have to like save it before we do that. All right. So that's how we get the old B. And then like that's the body of the loop. Eventually it'll stop and it holds the greatest common divisor. Cool. So let's try that. I'll call it gcd.cpp. So I definitely need two numbers, right? A and B. So I'll declare them both. I can use this comma to declare multiple int variables at once on the same line. And then I'll ask the user, hey, enter two numbers. And then just like you can give multiple things to cout, you can ask for multiple things from cin. So you can do this. Cin A and B. And what it will do is it will stop waiting for the and wait for the user to type again. And as long as the user space separates in some way with like new lines or even just normal spaces or even tabs, as long as the user separates the two numbers, it'll get them both at once. All right, so that's how that works. I'll show that too. And then once I have those two numbers, let's do this algorithm. So while B is not 0, I would like to replace B with the remainder from dividing A by B. So B equals A mod B. And then I want to say A equals old B as well. And so that's the value before I did this, right? So I have to save old B really quick right here. So give me the current value of B, save it safely, then I can mess with B, and then the old B holds the real, original, old value of B that I can replace it into A with. So yeah, eventually, right, the loop will stop, and the only way for this to be false would be for B to actually be 0. And so when B is 0, we'll stop the loop, and A will hold the GCD, and that's our final answer. Boop. So yeah, that's the secret. And here, let me show you what I meant by getting two things from cin at once. So I can do it like this. I can be like 12 space 18. And I'm waiting on this line. Cin will get both of them as long as they're like separated by some amount of white space. I could also say 12 enter 18. Like it's still going to wait until it gets 2 ints. So yeah, you can get them all on the same line as long as you space separate them. And then here it is, it's working. It's calculating 6, all right, which is the correct answer. It'll work for any number, even giant ones. Apparently these two random button mashing numbers have 14 in common. That's the biggest number. So yeah, that's pretty cool. That's a great algorithm and very fast, very efficient. And it was the first algorithm ever invented. You have enough tools now to write it. That's very cool. All right, so there's that one. Let's also do guess the number game because we can make this work for real now, can't we? So let me copy in. Let me copy in all the stuff from last time. Copy lecture 5's guess.cpp to here, and then let's go into that one. So I don't like this, right? I just like repeated this 16 times, I think. Disgusting. Let's get rid of all but one. Because essentially, right, I want to repeat this code. I want to repeat this code as many times as it takes for the user to get the answer right. So I had a guess variable, that's the user's guess. I had an n variable, that's the secret number. I want to keep asking for a guess and checking it while, right, while the user hasn't gotten it right. So this is my condition. While guess is not equal to my secret number, I guess I called it n, so while guess is not equal to n, just keep on asking and checking that number. That's it, okay? That's what we need to do. So like this is the ask for a number and check it. Just while I don't have the right answer yet, keep doing that. That's my loop. I want to repeat this code in that way. So let's see. I'll do it up here. While guess is not equal to the number n. Repeat all of that, right? Does that make sense? Like that's the right condition. While guess is not equal to n. Do this. I do have an issue the very first time though, don't I? Because it's going to check this once, right? To run the body the very first time to ask for the very first guess. What's the value of n? What's the value of guess right now? Is it okay for me to do this comparison? N will hold for sure the secret number, but what about guess? It's going to hold garbage, won't it? The very first time this gets checked, because I haven't read anything into the guess variable yet. So that's an issue. I should do something about that, because technically it might just so happen, right? The random number that was in guess, it's very unlikely, but this random number that was in guess might be the right number the very first time. It won't even ask the user. It'll just stop the loop, won't it? So, and then the user will be very, very confused. So, in a very, very unlikely chance that guess is equal to n the very first time, let's hard code it and make sure the very first time we check this that guess is definitely not the number. All right, so this is a random number between 1 and 100. Let's just start guess at like -1 to make sure the very first time we run this, guess is not equal to n for sure. Now we know. All right, so that's important. And then yeah, we just keep on repeating while it's not equal to n. I actually don't even need this exit anymore, because watch, if guess is not equal to n, like we write in the right guess, it was equal, we hit this else, we print you got it, and we come back to this condition. If we got it, guess was equal to n. That will stop the loop, which will come down here and end the program normally. That's pretty neat. All right, so that's it. That's the secret. That's the full program now. It's gonna do the right thing, and we get the added bonus that it will just like work as many times as you need it to. Because like if you have a child play it and they don't know how to do it right, they just keep guessing the same number too many times. It will never stop still. It will always work and keep on waiting until the user gives you the right number, right? Only then will it stop this loop. It can go infinitely many times if necessary. But hopefully, somebody will eventually get the right answer. So I can just keep guessing 5. More than 16 times. I can guess it 1,000,000 times if I want to. It's always just going to be like, all right, still not equal. I'll ask for a new number. So this is the right way to program this. All right, so let's do it right. 75, 65, 70, 72. Ooh, it's 71. Yay. So this is the right way to program this. It's only 26 lines. It's much better. Okay. So yeah, stare at this one. Ask me any questions that you have about it. But that's a great motivating example for needing loops. Okay. So this is all about while loops. There's actually a different kind of loop in C++. There's one more that I want to teach you. It's called a for loop. All right. And so as you would expect, it starts with the word for, and it looks very weird. All right. What a for loop looks like is in between parentheses, you don't just put a condition, you put 3 things. You put what I like to call an initialization, then the condition after a semicolon, and then something that I like to call the increment, though it might end up being blank or something completely different than that, but usually it's used for increment purposes. And then notice that you don't put a semicolon right here, even though you're going to put like something that would be a statement in C++. It's very weird, very disgusting, but I promise that eventually you will come to love the for loop, all right? But really, it's just a special kind of while loop. You do not gain anything. A while loop is enough to do everything, right? So a for loop gives you no extra power, but it is useful for certain kinds of loops, all right? So it looks like this. You could have done it with a while loop. and then here is how a for loop works. All right, so you come into it in the before land, and then you hit the loop, and then how does it run? What it does first is it runs the initialization part. It runs that code only once. It never comes back to init, but it starts with that. And then it runs, checks the condition. As long as the condition is true, it runs the body and the increment in that order. So it's always condition, body, increment, condition, body, increment. It always keeps coming back to check the condition, as usual, but that's how it works. All right, so it's always condition, body, and then the increment part's over here. It runs that after the body. Then it comes back to the condition. Condition, body, increment. Condition, body, increment. All right, that's weird to think about, but it works. And then eventually the condition becomes false and you're done. That just stops the loop as usual. All right, so let me show you how to print from 1 to 10 with a for loop. All right, it's going to look a little weird, but I promise you'll get used to it and you might prefer it. So let's see. I'll steal this code so that you can see that. See that it's very similar. 1 to 10 for.cpp. So here, let me just start with this. Let me show you how to translate this, transform it into the equivalent while loop. So I'll take essentially all this code and do it all over again with a for loop. All right, so here's how you do it. For, then I put an initialization. Like, what do I want to initialize? What do I need to do first? You see how that's this line? I want to initialize an I variable. Int I equals 1, semicolon. Put the condition of the loop, that's just this, right? I less than or equal to 10, that can stay. And then we'll figure out the increment in just a second. And then we put the body, right? That was this. But notice how there is an increment statement, isn't there? Right? There is an increment statement. It's this I++. So that we tend to move to here, I++. Oops, like that. Does that make sense? And so at a glance, you can kind of easily see on the very first line what's happening with the I variable. And then the body is like where you do the real work, where you actually use the I variable for your special purpose. So that's why people prefer for loops for many things. So only the, like, quote, real work goes in the body now. So you can just, on the very first line, you can easily see, like, all right, this makes an I variable, and it increments it by 1 until it's 10. So I ranges from 1 to 10. 1, 2, 3, all the way to 10. You can read all of that off the first line, and then the body's like, all right, what are you doing with I? It's printing it. So it's printing from 1 to 10. That's how I think about it. Okay? So it's all the same, though. You gain nothing. It is just a different way of writing that while loop. It's exactly the same as that while loop. Boop. And so, yeah, there it goes. Prints from 1 to 10, as you would expect. Instead of this code, just got transformed into this code. And I promise you, you'll eventually like this way for simple loops that just like increment a variable in some way. Like this will take care of pretty much everything we've been doing. When you have something that like corresponds to an initialization and an increment, a for loop is what you use. You don't really want a for loop for this program because there is no concept of like, what am I initializing? I'm not incrementing anything at all, right? So a while loop is more generic in that sense. You have more control, but usually, sometimes, a for loop can be what you reach for because a lot of our programs, they're like making some variables that are working on a range of numbers, all right, among other things. So yeah, let me go to this code and just draw for you again why it's working. We'll consult this diagram, right? So why is this working? What's it doing? So again, the very first thing a for loop does is runs its initialization line just once and only once. So you can create a variable there, which is cool to think about. So I is 1, and then it does condition, body, increment, as long as the condition was true. So is 1 less than or equal to 10? Sure. Print the 1, and then increment, I++. Boop. So, and then it's just like condition, body, increment. Is 2 less than or equal to 10? Yes. Runs the body. Runs the increment. So prints the 2, I++ makes I3. And I think you can see condition, body, increment. It's going to print 3, make it 4. Condition, body, increment is going to print the 4, make it 5, all the way down to, like, it's going to print 10, right? So we get condition, hey, when I is 10, that's true, right? Still less than or equal to 10. It's going to do body increment one last time. So print the 10, make it 11. So I++, and then we come back to the condition, and then it's false, right? 11 is not less than or equal to 10, so that will stop our loop having printed just up to 10, right? So that's why it works. So yeah, it's just, this diagram looks a little bit different. Just remember the initialization only works once, and the increment is after the body, right? But it's very similar to a while loop, okay? So yeah, with that, your turn. Try again. Here's that code that prints from 1 to 10, just in different colors. Change this, instead of printing from 1 to 10, tell it to print from 20 down to -5, including all those numbers, going by 5s. All right? See if you can figure that out. So yeah, definitely pause and try this. This is a great example to practice with. Let's see. So yeah, what needs to change? You see it? So I think you're pros now. You know that the very first thing, your initialized variable, needs to start at the thing you're starting with. Start at the value you want to print first. So instead of 1, this should be 20, right? Now that's a semicolon. I need to keep it visible, right? So that should start at 20. And then we're going 20, 15, all the way to -5. We want to stop once it gets any smaller. Like once it gets -10, we want to stop for sure. And so checking this, like, we totally need to change this to be I something involving -5, right? I something involving -5. It's definitely not less than or equal to, because like the 20 is not less than or equal to. It will never even run. So that should be a hint as to like when you're making your way up, it's less than or equal to. When you're making your way down, it's greater than or equal to. Because 20 is greater than or equal to -5. -5 is greater than or equal to -5, but -10, no, it's not. All right, that's how it's going to stop. So it's like we put a wall and we're going in this direction. There's our wall. It's our greater than or equal to. We want to take only the things above here, above the wall. All right, so there's that. And then finally, I++. We don't want to go up by 1. We don't want to make 20, 21. We would like to make 20, 15, 15, 10. So what needs to go there is like I equals I minus 5, right? That's what you put there. And you don't put a semicolon. There is no semicolon. It's weird. But like that's the name of the game, okay? So there is shorthand for this one, right? It's I minus equals 5. And so, yeah, I think that would do it, right? And just like, let me show you this shorthand again. In terms of pluses, we have a bunch of different ways to increment a variable, right? You have I++. You have, that's equivalent, right? The full way is I equals I plus 1. And then there's like some middle ground shorthand that is I plus equals 1, all right? So like those are your ways of doing it. This is only by 1. There is an I minus minus that goes down by 1. But if you want more control, like you want to go by 5s, it's minus equals, okay? But it's all just shorthand for this thing. That's the full way of specifying it, okay? So yeah, I don't think I need to code this up. I think you see what it's going to do. Hopefully you tried to code it up and you ran it and you confirmed that it worked. So yeah, just a couple more things that I want to talk about for this lecture. Let's talk about what's called the scope of variables next, because we have like new braces. Braces are very important in C++. Like in if statements, you add braces as well, right? Those create what's called a scope, all right? And fancy things happen there. So a scope just kind of tells you, depending on which scope you're in, it tells you which variables are alive, and then also visible and able to be like used and printed out and stuff like that. So where I'm going with this is that like once you make braces, like inside the main function, inside of loops and conditions and things, you can make your own variables, right? You can make your own variables, and the secret is those variables only live between those braces, all right? So they might die early. So like here are some blue braces, start here and end here, let's say. You can start making variables, like say this is the main function. Be like int I equals 42, sure. You can do that. But then maybe you come along and you say, like in an if statements body, or in a while loops body, you can make some other variable. You can make int I again, right? You can make another I. It's possible. It's not good, but you can do this, all right? Int I, let's say, equals 55. And then you work with that I somehow, like I++ or whatever. You can do weird stuff like that. And when you mess with the I and you use I in the green braces, it's in an inner scope, we say, you get this I stuff. There is a separate blue I, blue braces I guess. Okay, so that's what I'm trying to say here. So you can make a variable in an inner scope, inner braces, braces within braces, with the same name as a variable in the outer scope, and the closest one gets priority. It's a brand new variable. It's gonna shadow the other one, we say, so you don't have access to this one anymore, even if you wanted it. And it's a horrible idea. All right, you should never do this, but it will work if you ever need it. All right, so like what will happen in this code is like, all right, it'll make the blue I, like it's running your code, like runs this line, makes I42, and then it comes to the green stuff, and it's like, all right, I equals 55. It makes a brand new I. It's a green I. Both of these variables are alive at once inside the green braces, though you cannot access this one anymore. You've just shadowed it, all right? The I++ hits this I, makes it 56. I hope that makes sense. Makes it 56. And then the second this green brace is done, then the I goes away, all right? The entire I variable gets reclaimed, deleted, and then you're back to just this one. If you talk about I down here, you're getting the blue I, the original one. Okay, so you can do that. That's totally possible. You can make, hopefully, when you make inner scopes, you use new variable names, like you say int j or something, and you work with j instead of I. But again, like between these braces, like this line is where the j begins its life. Whee. And then this brace is where the j ends its life. So you can't even use the j out here in between. All right, it's like it only lives for the life of its enclosing braces for every variable. All right. That's what scope means, where variables are alive. And so here, let's make some braces. You can make braces as part of like for loops and if statements. You can also just like make them for fun, not part of anything. Like I can make some inner braces. That's totally okay as far as C++ is concerned. So here, let's make some variables. Be like int x equals 42. I'm just going to write some code. Then I want you to like think in your mind about what's going to happen. How is it going to like print things? So I'll make an inner brace, inner scope. Just keep going, why not? Let's do this, 100, and then see out x here, see out x here after this curly brace close. Okay, what is going to get printed here? What do you think? Do you see it? You see what's going to happen? For sure 42 is going to get printed first. But what about after that? Can you read it? So the 10 was from what was above from before. So here's 42, print 42, it makes the 42 variable, cool. And then inner scope. You see it's going to make a 55 variable called x. It's going to shadow this one, then it prints 55 because you're getting the closest one always. And we make an inner scope, a shadowed x, so like 55 and 42, we can't even access those x's anymore. We got this one now between these braces. You print the 100, and now things start dying. All right, this closing brace kills this x, and now we're back to the closest one is this one, 55. So this will print 55. All right, does that make sense? Then this closing brace closes off all of these guys. It kills the 55 variable, and then we're back to this x, the 42. That's why we print that one. All right, and then of course after that closing curly brace, this is where x began its life, right here. It's attached to this curly brace. If I try to output x outside, then I'm going to get a compiler error because the x died right here. It doesn't exist anymore. And the compiler is helpful. It's like x was not declared in this scope. See the word? So there it is. That's what that means now. All right. It used to exist potentially, but it doesn't anymore. So got to get rid of that line. So that's the secret. All right. You'll also see this error when you misspell a variable, because it's like that variable didn't exist anywhere. So yeah, x was out of scope. We said it was. It got reclaimed. The memory went away. So yeah, that's how scope works. That's how long variables live, and I hope that makes sense. So actually, technically, for loops have their own scope. Or was that? No, it was the same program. For loops, they create this I variable, and actually the I variable is in an inner scope. It ends. There is no I after this program's over. So yeah, that was in an inner scope. See the error there? Oops. So yeah, I think that's what I wanted to say for all that. That's the scope of variables. And then I guess the last thing I want to do is just like give you a demo of like somebody actually using loops for something cool. So like instead of just printing from 1 to 10, like that's cool, sure, you can do fun stuff, print times tables, I guess. But here's like a real example that's like gonna motivate, like why do we need loops in the first place? I think the guess the number game was a good example as well. But let's do this example. It'll be a good example of a for loop. So let's lowercase a string, all right? Let's go through an entire string. I mean that, right? Go through a whole string, not just the first character, and lowercase everything, all right? So like let's say that I have this string S, and the user shouted at me and they gave all caps blah in S. What I'd like to do is go and visit every index of this string S, right? Every single index, and mess with all the characters there. Use the CC types toLower function, right? I'll use that. But I want to call it on all these to make lowercase letters and shove it right back into that same index, all right? So that's what I like to do. I'll use toLower on each index, and that's part of CC type, remember? And that's what I want to do with the string, all right? So the secret is to make this a loop. I just kind of want to increment a variable that will talk about which index I'm working on. Does that kind of make sense? That's the secret. It's like I'll start off in index variable. That's one reason why we use I. That's like a standard loop variable name. We'll start at 0 because that's the first index I want to mess with. And then I'll be like S at I, right? Because the first time it's 0 equals like toLower of itself. And then like I++. See that? Make it 1. Make it 2. And that will, like, as I ranges, and I keep repeating the body, it's like it's working on index I. So I will be 0, 1, 2, 3. It'll have a chance at being everybody. You see that? That's the secret. And I just want to iterate as long as I is a valid index of my string. What's my condition there? Like for this string, it's size, the string is size 4, right? But maybe like I have a longer string that I want to go through. Hopefully you can see that the last index that I want to visit ever is always dependent on the size. We talked about that, right? So I just kind of want to keep going while I is less than, I guess 4. You can do strictly less than or equal to 3, or strictly less than 4. And that maybe is easier because like 4 is the same as, it's always like your string size. So that can be my condition. While I is less than the string size, mess with S at I++. Okay? You see how it's all coming together? So let's do that. Let me code that for you. A great way to practice is to try it before I do it as well. But if not that, do try it out yourself after I'm done. So here, let's ask the user for a word. We'll just get a single word only. But you could do this with getLine, get an entire sentence if you wanted to, and our word. And then, let's see, I need a few libraries, right? I need to make string variables, and then I need to use the toLower function, if I can spell the name of the library. So I've got a single word from the user, because I use cn, and now I want to iterate. Oh, I should use this word, right? Here's a new word I'm teaching you. So I'm going through every index of S. That's what I want to do. Another word for that is iterate. It's a nice Latin rooty word. So we say that we iterate through a string when we go through it. Essentially, we're visiting all of its indices. So in general, loops are always iterating over something a lot of the time. When you're going with numbers, at least, like this loop iterates from 20 to -5, we say. So like that's a new term. You're going to hear me say that a lot. So the loop is iterating. It's going through something. Iterate just means to go. All right, so yeah, what I want to do is iterate through every valid index of the string S, replacing each character I see with its lowercase version, if it's capital. So toLower is going to take care of all that for me. And so, yeah, the very first index, we're going to do it in terms of indices. The very first index I want to visit is index 0. So that's the first index of every string. And then I want to keep going, right, while I is a valid index. So while I is less than s.size. You see how that will always be a valid index for any string. Like if it's size 4, it's going to make sure I will go from 0, 1, 2, all the way up to 3, strictly smaller than 4, the size of it. All right, no matter how long the string is, it's always going to work. And then I'll say s at I equals whatever it was. So take whatever index I'm looking at and keep it the same, though I want to lowercase it, toLower. It's the one thing I want to do to it. lowercase whatever was there and replace it. Does that make sense? That's what I want to do. And so I is going to range from 0 to 1 to 2 to 3 as long as I do the I++, right? The very first time it's going to mess with index 0, then it's going to mess with index 1, increment it to 2, and mess with index 2 as long as there is an index 2, as long as this is a valid index. So for my blah string, it'll like go to index 3, mess with it, make index 4, but that's equal to the size, so it'll stop the loop. Okay, so that should do it, and then we can print out the new version of the string. So here, let's do it. Enter our word, all caps blah. It made it lowercase. It visited every single index and never tried to go outside. It went to all the valid indices of my string. And that's perfect. So here, if I run it again, give it all caps my name, it'll make lowercase my name. So no matter what the last index is, like the size is going to figure out, and we'll get the right stuff. The last index that I try to mess with is always going to be a good index. It's always going to really be the last one. Okay, so that's perfect. That's working very well. So that was a while loop version. We can do a for loop version as well. So do you see how it's going to need to change? So let's, I guess I'll comment this out because I only want to do the process one. So we know it works this way. Then I'll take this again and we'll do a for loop version. Oops. That needs to go there. There we go. So instead of this, let's change it to 4. And so here is my condition. Boop. Goes there. Or sorry, my increment. I'm getting every word wrong. Excuse me. That's my initialization. I said every one that it couldn't have been. This is my initialization part of my loop. And then the condition is next. And then the increment is down here. That's the I++. So that moves to be here. I++. There we go. So yeah, this is, again, I like the for loop version because you can see like what's happening for I. It's ranging through every valid index of the string s. Like I can see that on the very first line, and then the body is just like the real work. Like what am I doing at each index essentially? So there it goes. It's going to work again. And so if I rerun it, there is no change because these are equivalent pieces of code. You could have written either one. They'll do the exact same thing. All right, but sometimes you will prefer a for loop over a while loop. And I usually like for loops when it's like a range over numbers. So this is a range over numbers. And so I usually prefer a for loop for that. But you could have used a while loop if you wanted to. So yeah, that's a good little example to end us off, like doing something that you might want to do for real one day rather than just printing numbers in order. So yeah, we'll get some more fancier examples next time because I think this is where I want to stop. All right, so that's enough loops for one day. Let's come back later and do some more, and I'll see you then.